Hello my dear students, Assalamu alaikum. Our today's topic is infinite geometric series. What is infinite geometric series? An infinite series is a series whose terms continue forever. Suppose we are taking here a geometric series with the first term a is equal to 2 and common ratio we are taking here 1 by 2. Common ratio 1 by 2, then we will get the series. First term is here is 2, then second term will be, first term is 2, then second term will be, AR, that will be AR, then AR square, AR cube, and up to so on. This type of series is geometric series. Then here second term will be this into this, 2 into 1 by 2 will be 1, then the third term will be 1 by 2, then fourth term will be here 1 by 4, then 1 by 8, and so on. This will be the geometric series with a is equal to 2 and r mean the common ratio 1 divided by 2. For this series, it can be shown that sum up to first term, that is 2. Sum for the first two terms, sum for the first two terms, these first two terms will be S2 is, here 2 plus 1 is 3. In the same way, for the first three terms, what will be the sum? S3 will be here, S3, that will be equal to 2 plus 1 plus 1 by 2, that will be 3.5 up to here, that will be 3.5. Then after that, sum for the first four terms, S4 will be equal to, first four terms are these first four terms up to here, these four terms, okay, and S4 will be equal to here 3 whole 3 by 4, 3 whole 3 divided by 4. Then for first five terms, what will be the sum? That will be 3 whole 7 divided by 8 up to here. This one is 3 whole 7 divided by 8. From these terms, what we can get, here is 2, 3, 3.5, 3 whole 3 by 4, then 3 whole 7 by 8. These sum approaches to the number 4. These sums approaches to the number 4. It will more closer to for 6 terms, sum will be more closer to 4, then again more closer to 4. It will never be 4, but it approaches to 4. This is an example of convergent series because the sum is to infinity converge on the number 4. Okay, this is the convergent series. Consider that the geometric series A, AR, AR square, AR cube, and so on, AR raised to the power n minus 1. Consider this geometric series. What will be the sum of this geometric series? Sn we are representing sum with Sn, that will be a into 1 minus r raised to the power n divided by 1 minus r. If here this r will be in between -1 and 1, mean here -1 less than r is less than 1, r in between -1 and 1, then as n gets larger and larger, n gets larger and larger, mean first term, the second term, third term, n is going to increase larger and larger, then r raised to the power n, what it will gives us, then r raised to the power n gets closer and closer to 0. Okay, look here, if in between these two, this will be in fraction 1 divided by 2 or -1 by 2 or 1 by 3, like that. When we will place here n 1 2 3, mean any number of term we will place here, this r raised to the power n will approaches to 0. We can say when n is approaches to infinity, n approaches to infinity, then r raised to the power n approaches to 0. When n approaches to infinity, r raised to the power n approaches to 0. Then we can get the formula, this Sn is equal to a into 1 minus this r raised to the power n, this approaches to 0, divided by 1 minus r. Then we can write this Sn a divided by 1 minus r. This is the formula to find the sum of infinite geometric series. For the finite geometric series, already we discussed in the previous exercise, this formula is to find the sum of infinite geometric series. Now we are going to start exercise related to infinite geometric series, that is exercise 11.5. Question number 1 is, this infinite geometric series is given here, that is 3 plus 1 plus 1 by 3 plus 1 divided by 9 and so on. We need to find the sum of this infinite geometric series. What is the first term of this series? That is 3. What will be the common ratio? R. R is we will take the ratio of any two consecutive succeeding and preceding terms, like second divided by first, or the third term divided by second term, or the fourth term divided by third term. Here second divided by first, 1 divided by 3, easily we are getting here r, that is 1 divided by 3. Then we will apply here the formula to find the sum of infinite series. S infinity is equal to a over 1 minus r. What is a? A is the first term, that is 3 over 1 minus r, common ratio, that is 1 divided by 3. Then 3 divided by here 1 minus 1 by 3, we have to take the LCM here, 3, then 3 into 1 3, 3 minus 1, that will be 2, 3 into 1 3, 3 minus 1, 2 by 3. Then this we will shift into the numerator, that will be 3 3s are 9 divided by 2 and 9 by 2, you know, that will be 4.5. Now question number 2 is, the first term of a geometric progression is 10. First term we are representing with a. Question number 2, first term is 10 and the second term is 8. First term, then we will say a1 and the second term will be a2, that is 8. Find the sum to infinity. Sum to infinity. How we can get the sum? For that we need first term and the common ratio. First term is already given here. Now we will find the common ratio, that will be second term divided by first term. 8 divided by 10, we can write 4 divided by 5. Then sum to infinity, that will be a1 over 1 minus r. First term here is 10 divided by 1 minus r is 4 by 5. After further simplification, 10 divided by here 4 into 5 into 1 5, 5 minus 4 is 1 divided by 5, 10 into this 1 by 5 in numerator will be 5 by 1, and 10 fives are 50. 50 will be the sum of this infinite geometric series. Then after that, question number 3 is, the first term of geometric progression is 300. Question number 3, first term of geometric progression, that is 300, and the fourth term is minus 2 whole 2 by 5. Fourth term is minus 2 whole 2 divided by 5. We can write 2 5s are 10 and 2 12, minus 12 divided by 5. Find the common ratio and sum to infinity. Common ratio and sum to infinity mean we need to find the value of r and s infinity. These two things we need here. Now, first of all, we will find common ratio. For common ratio, as general term of geometric progression, an is equal to a1 r raised to the power n minus 1. Here at the place of n we need to substitute 4 because fourth term is given here. Fourth term is given here, due to that n we are using here 4. A1 first term is 300, r as it is, and already we have taken here 4 minus 1. A4 is minus 12 by 5 is equal to 300, r raised to the power 4 minus 1 is 3. Now this minus 12 divided by this 300 here, this side we will shift, it will be 5 3s are 1500 is equal to r cube. Then r cube will be equal to this 12 divided by 1500. When we will simplify, this will gives us minus 1 divided by 125. You can check with the help of calculator here. 125 12s are 1500. Then r cube is equal to minus 1 divided by, 5 cube is 125. 5 cube is 125. It means this will gives us r is equal to minus 1 by 5. This is value of r. This is the value of r. Then after that, s infinity. S infinity will be a1 over 1 minus r. A1, the first term is 300 divided by 1 minus r. 1 minus r. R is minus 1 by 5. Minus into this minus is plus 1 by 5. Then this will gives us 5 into 1, 5 plus 1, 6 divided by 5. Okay. Then this 300, this 6 by 5 in numerator will be 5 divided by 6. This 6 cancel with this, here will be 5 6 are 30 and 55s are 250. It means s infinity, sum to infinity term is 250. Next question is, the first 4 terms of geometric progression are 1.8 square. Question 4 is geometric square 1, then 0.8 square, then 0.8 raised to the power 4, then 0.8 raised to the power 6, and so on. Find the sum to infinity. Find the sum to infinity. Formula to find the sum to infinity term, that will be a1 over 1 minus r. for this thing we need first term and the common ratio. A1 first term already here, that is 1. What will be the common ratio? That is second divided by first. 0.8 square divided by 1, that will be 0.8 square. That will be 0.8 square. Then we have to substitute here. A1 is 1 over 1 minus 0.8 square. This will gives us 1 minus 0.8 square is 0.64. Then 1 divided by 1 minus 0.64, that will be 0.36. 1 divided by 0.36 is 2.78, or if in whole number you need to write, then 2 whole. After that it will be 7 divided by 9. In this way also you can write.